Okay, recitation 4 is all about the polynomial functions. So let's see the first question. We want to identify the degree and behavior roots with multiplicity of these polynomials. So let's see A. A, we have 4 factors: x cubed, x plus 1, x squared plus 9, x squared minus 4. So 4 factors. The degree will be adding all the exponents of each factor. So the first factor has exponent of 3. And the second factor is a perfect square. If we expand this out, we get x squared plus 2x plus 1. So here, the exponent is 2. The leading term, just consider the leading term here. Exponent is 2. And the third factor leading term is with square. The fourth one also with the square. So the degree will be adding all those exponents up because each one is a factor, right? Factor means with multiplication. Multiplication of the same base, we add the exponents. So I have 3 plus 2 plus 2 plus 2, 9. So the degree of the first one is 9. N behavior, right? 9 is odd. So this is the odd degree of polynomial. Remember, odd degree polynomial have 2 kinds of N behavior. Either this is with a positive coefficient, right? With a negative coefficient, the odd degree of polynomial has this kind of N behavior. Okay, so we know it's odd degree. Now, what about the leading coefficient? So in this factor, the leading coefficient is 1. In this factor, the leading coefficient is 1. In this factor, leading coefficient is 1. In this factor, leading coefficient is 1. 1 times 1 times 1 times 1, still 1. So positive, so this one. So how do we use words to represent this ending behavior? This arrow means x value keeps going to positive infinity, right? This is for x value. And also the y value, the function value also keeps going to positive infinity. The function value, f of x. So in words, we read that when x approaches infinity, f of x also approaches infinity. So this arrow means when x goes to negative infinity, right? That's negative infinity. And the function value also goes to negative infinity. Oh, you can put an arrow this side or on the other side, doesn't matter, okay. That's for A. For B, let's do the same thing. We'll have 4 factors. We'll have x squared minus 9, x squared minus 2, x plus 7. Oh, one more thing. We need to find the n roots with multiplicity for the first one. So the roots, first, x equals to 0, right? Because x cubed, when the function equals to 0, each factor can be 0. That means x cubed can be 0, which means x can be 0. When x plus 1 is 0, x equals to negative 1. When x squared plus 9, well, x squared plus 9 in real number system will never be 0. But then last one, x squared minus 4 can be factored as x plus 2 times x minus 2. We'll have minus 2 and plus 2 as roots. So I have 1, 2, 3, 4, 4 real roots. 4 real roots, 2 complex roots come from x squared plus 9. What about multiplicity? Negative 1 has let's mark with this. So negative 1 has a multiplicity of 2, right? Because it's a perfect square. So we have 2, so negative 1, we have 2. We have same roots twice. Negative 1 to be the roots twice. So let's see B. Let's figure out degree first. So if we expand this, the leading term will have 6 degrees, right? You see, x raised by square, then raised by 3 again. So 2 times 3 is 6. So degree from here is 6. Degree from x is 1. Degree here 2. Degree here is 7. So add all those exponents. 1 plus 6, 7. 7 plus 2, 9. 9 plus 7, 16. Even degree. So the degree is 16 even. Now the coefficient is positive because we have 4, we have 1, we have 1, we have 1. So it's positive. With the even degree, we have 2 unbehavior. If the leading coefficient is positive, we have this. If the leading coefficient is negative, we have this, right? And we need to use, so this is a picture of the unbehavior. We need to use a word to describe. So this arrow is seen when x approaches positive infinity, f of x approaches positive infinity, just like this one. This arrow is seen when x approaches negative infinity, f of x approaches to positive infinity. That's for those two. Oh, roots. Roots, we get 0 from here. When x equals, when function equals 0, each factor can be 0. That means x can be 0, so 0. X squared minus 9, difference of 2 squares, plus minus 3, because it can be split into x plus 3, x minus 3. From here, we have square root 2, right? Difference of 2 squares, plus or minus square root of 2. From this one, negative 6. So negative 6 has multiplicity of 7. And the plus minus 3 has multiplicity of 3. Let's see 2. Question 2, we need to write out the polynomial function. So start with f of x equals to. So degree is 3. So we have 3 factors. So we have roots of minus 2. Minus 2 means x plus 2. Then x minus 1, because 1 is a root. But 1 is a root have multiplicity of 2. That means x minus 1 raised by 2. Leading coefficient is 2. Add back here. And that's it. Leading coefficient is 2. Have a root of negative 2 and negative 1 with multiplicity of 2. Let's see 2. Let's see B. B. We always start with the f of x. F of x equals to, well, leading coefficient is 1, negative 1. So let's put a negative 1 here. And has root 1 minus I, complex root. Then has negative 3, so we write x plus 3 and x, right? X. So we have negative x, then times x plus 3. Then we have complex root of x. Let's put it right here. So x minus 1. Oh, let's do plus first. X plus 1 minus I. And x minus 1 minus I become plus I. But usually we don't want to leave I in the polynomial function. So what do? We need to simplify this. So that equals to negative x times x plus 3. Then x plus 1 minus I, x minus 1 minus I. Actually, we can use difference of 2 squares, right? Oops. So that we get x squared minus 1, so x squared minus 1 minus I squared. Okay. So because if we don't simplify this one, let me write again. So x minus, so we have one positive, one minus I, we have one plus I. Okay, so x minus one minus I, x minus one plus I. So x minus, maybe I use bracket, it's easier. X minus one minus I. That's one root. And another root is x minus, remember complex roots come in pairs, conjugates, 1 plus I. Okay, this is more obvious. You see this x minus 1 minus I, x minus 1 plus I. So this is simplified to be what I wrote before. But let me write it one more time again. So the first one becomes x minus 1 plus I, right? Minus I become plus. The second one becomes x minus 1 minus I. You see that? Oh, the first one, this should be 1, not I. I wrote 2 i's there. So x minus 1, this is 1. X minus 1 plus I, x minus 1 minus I. So now we can treat x minus 1 as one thing. You see, we have a something plus I, something minus I. So we get something square, x minus 1 square minus I squared, right? Difference of two squares. What's I squared? 1. Negative 1, I mean. So negative 1 become plus 1. So this becomes x minus 1 squared plus 1, right? So this one, so now we can write the whole thing as negative x times x plus 3 times, let's use bracket, times x minus 1 squared plus 1. What is that? We can also simplify, right? Usually we don't write in that kind of format. So negative x times x plus 3. Simplify this one. Perfect square of x minus 1 square, which is x squared minus 2x plus 1. Plus 1 plus 1 plus 2. So this one becomes x squared minus 2x plus 2. And that's it. So that's the function for the characteristics given. Degree 4 has root 1 minus I. If 1 minus I is root, 1 plus I is also root, because complex roots coming in conjugate pairs. The negative 3 is 0, leading coefficient is negative 1. All right, so that's it. That's for this one. Let's see 3. We want to match the polynomial functions to its graph. So how do we do that? Let's see the first one, I. A is given as positive constant. All right, so A is positive, negative A is negative. So this one has a negative leading coefficient and degree is 6. So we know that N behavior is 2 hands down, right? So we're looking for 2 hands down. That's it, only C. Only C can be I, right? 2 hands down. And if we check the roots, use the roots is negative 2 and 3. We'll check the roots. Negative 2 and 3, bingo. So I is, what's this number? C. I is C. Well, let's see, 1 is C. 2 leading coefficients positive. Let's count the degrees. 3 plus 1 plus 1, 5. So that means red arms up, left arm down. And we have roots of negative 2, positive 2, and 4. So plus minus 2. So left hand, red arm up. So could be A. Well, let's check A. Well, A has roots of negative 5, negative 3, 0, and 2. No, not this one. Or it has to be F then. The roots is -2, +2, +4. Bingo. And the right arms up, left arms down. F. So 2 is F. Let's see 3. Negative leading coefficient. Let's count the degree. Degree 5. Okay, that means left arms up, right arms down. And it has roots 1, -4, and 6. Could be this one, could be D. -4, 1, and 6. Bingo. So D is 3. Let's see 4. Positive leading coefficient, degree 4. Both arms up. And then we have +-1, +-3 as, that's it, this one, +-1, +-3, both arms up, so B. So 4 is B. Let's see 5. Positive leading coefficient, degree 2, 3, 4, 5. Right arms up, left arms down, could be 8. -5, -3, 0, 2. Bingo, yes, right? And the 0 has multiplicity of 2. If you say touches, turn around. So 5 is 8. Lastly, 6. Degree 4, positive. Both arms up. Roots, -1, 2, and 4. -1, 2, and 4. -1, 2, and 4. -1, or 2 and 4. Oh, -1 is not. Oh, right, -1 is not because we have x squared plus 1. This is the complex roots. So I have 2 and 4. That's it. E. 2 and 4 as real roots. You see this goes up above x-axis, wiggles above x-axis. That tells us that's complex roots. Okay, that's all for this one.